Today we want to have a look at chemistry, and the topic we are treating is base. The previous topic was on acid. Now, what is a base? According to the definition written on the board, any substance that can neutralize an acid to produce a salt and water only is a base. Yes. So, how do we now identify a base? Through formula. We can identify a base, one, by noting this, that every formula of a base starts with a metal and ends with oxygen. Or let me say, every formula of a base contains only a metal and oxygen. Only. Yes, that means it will contain only those two elements, a metal and oxygen combined together. Examples are these. And a metal and oxygen combined together is called oxide of metals. So that means oxide of metals are bases. Sodium oxide, calcium oxide, potassium oxide, and magnesium oxide. Also, a base formula contains a metal and an hydroxyl. OH, that's the hydroxyl group. A metal with an hydroxyl. Any compound that contains only a metal and an hydroxyl, only a metal and hydroxyl, is a what? Is a base. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, all are bases. However, we have a little difference between the oxides and the hydroxide. Let us have a look into that. All right. Among the metallic oxides we have discussed, majority of them are insoluble in water. The only ones that are soluble in water are potassium oxide, sodium oxide, and calcium oxide. And when we dissolve these three in water, it forms hydroxide. Remember, hydroxide and oxide are categories of a base. So when sodium oxide dissolves in water, it forms sodium hydroxide. Potassium oxide dissolves in water to form potassium hydroxide. And calcium oxide dissolves in water to form calcium hydroxide. Okay. Now look at this trend. Those hydroxides that are formed from these three are called alkalis. Why? Because alkalis are soluble hydroxide. That means only these three hydroxides are soluble in water. That means every other hydroxide aside these three are not soluble in water. Therefore, they cannot be called what? Alkalis. But they are still bases. So that means we can now say that all bases, we can say now that all alkalis are bases, but all bases are not alkalis. Alkalis, as I said, are what? Soluble hydroxide. I did not say soluble oxide. The fact that these oxides are soluble in water does not make them alkalis. So calcium oxide, potassium oxide, sodium oxide are not alkalis. But they are hydroxide, which further dissolves in what? Water, are called what? Alkalis. So definitely, by definition, alkalis are soluble hydroxides, and the few ones we have are sodium hydroxide, calcium hydroxide, and potassium hydroxide, and they are very, very useful in as raw materials in industries. Lest I forget, there is one other alkalis, but this one does not contain a metal, and that is what we call aqueous ammonia. Aqueous ammonia is another alkali. Aqueous ammonia. That is, when we dissolve ammonia gas in water, it gives aqueous ammonia, which is written as this. So, sorry. All right. So, when that dissolves in water, it gives the aqueous ammonia, which is this. Aqueous. AQ means aqueous. So, this is another alkali. Take note of that. These are the physical properties of bases or alkalis. Bitter taste, that means they taste bitter when tasted. Soapy to the touch, when we touch it, it feels slippery. That is what is meant by soapy. Then it turns red litmus blue. So when we take a red litmus paper and insert it in a base, it will turn blue. So let's take note of that. So the next thing now is chemical properties of bases or alkalis. Chemical properties of bases or alkalis. All bases will react with acid to form salts and water. This is a base. This is an alkali. Alkali of that's calcium hydroxide, calcium oxide. Form salt. Calcium chloride is a salt and water. But if you note, I want to take note of this second one. It's only alkalis that can do this. Only alkalis will react with what? Ammonium salt to liberate ammonia gas. In fact, this reaction is used to test for alkalis. If you want to know whether an alkali is present or not, just bring any ammonium salt, rather, please. Take note, any ammonium salt in contact with it, then ammonia gas will be liberated. This is ammonia gas. Ammonia is a gas. Ammonium salt is different from ammonia. Okay? Like this now, this is ammonium chloride. This is salt of ammonium. We have ammonium nitrate. That is the one that ends with NO3. We have ammonium sulfate, the one that ends with SO4, and so on. So, but whenever any of the ammonium salts react with an alkali, this gas will be liberated. And this gas, ammonia gas, please take note, is the only alkaline gas that turns red litmus to blue. So this is an important note. Ammonia gas is the only gas that behaves like a base. Why? It turns red litmus blue. and that is why it is called alkaline gas. Alkaline means the same thing as base. Okay, take note of that. Alkaline is different from alkali. Okay, alkali is a soluble hydroxide. Alkaline is another name for base. And don't forget, I said it earlier on, all alkalis are bases, but not all bases are alkalis. Thank you. So the final stage now is how to prepare base in the laboratory. Okay, we can prepare bases, one, through burning of some metals in oxygen. If we burn sodium in oxygen, or air, it gives sodium oxide. When we burn calcium in air or in oxygen, it gives calcium oxide. And also, by dissolving these ones, which are soluble oxides, in water, we get hydroxide, which is also a base and as well an alkali. So these are the two ways we can prepare bases in the laboratory. So finally, what are the uses of bases or alkalis? They are mostly used in industries where they produce glass, yes, and where they produce soap, yes. Those are the areas where they are used, okay, mostly. And as well, where they produce paper and many other things, such as softening hard water. If you want to soften hard water, we will use one of the alkalis. When we get to water as a topic, that will be discussed. My next video is going to be on pH scale. pH scale. Please do not miss it.